7.2b. Yes, I'm going backwards. 7.2c was an addition on Friday. I did skip B, and we're coming back to it now. So this one's kind of going a completely different direction. Instead of finding the roots from a polynomial, which is what we've been doing over and over and over again, this one I'm going to give you the roots and show you how to come up with the equation of the polynomial. So it's working backwards, but it's actually easier. Before I get to an example, I do need to talk to you about a couple theorems, and I'm going to write them down in Franken language because I think that the actual math language is very difficult. First one's called the complex conjugates theorem. Okay, the complex conjugates theorem says, generally, all roots with an I in it come in pairs. So when we get an I, when do we get an I answer? When we take a square root of a negative number, right? That's what causes an I to happen. And whenever we have a square root, we always have plus and minus. Yeah? That means that we're always going to have two answers when we have an I. So for example, if I get a root of I will always get a root of negative I also. Those two are called conjugates. If I get a root of 3i, I will always get a root of negative 3i as well. If I get something like 4 minus I will always get a root of 4 plus I as well. That's how we find the conjugates. Now, why is this important? Because when I tell you the roots of a polynomial, the way I'll try and trick you a little bit, or challenge you, maybe that's a better way of saying it, is I will tell you that I is a root, but I won't tell you that negative I is a root. You need to know that the i's come in pairs, so if I give you one, you need to assume the second one is also a root. Okay? Sort of make sense? Okay. Irrational conjugates theorem. Says basically the same thing, except it deals with radicals. Radicals also come in pairs. So if I have radical 2 as a root, then negative radical 2 is also a root. If I have 3 rad 17 as a root, then negative 3 rad 17 is also a root. And if I have 5 plus rad 3, then 5 minus rad 3 is also a root. And again, that comes from all of the plus minus things whenever we have a square root. Okay? So let's see an example. Now, I'm going to write the full instructions out for one example, and then you'll see why I'm not going to write the instructions out over and over again, but I want you to see what they are. So here's how it'll look. It'll say, write a polynomial function f, and I'll interpret this in a minute, of least degree that has integral coefficients and zeros of 4, -1, and radical 5. Okay, so I'll give you a minute to write that, and then I'll translate it for you before we start solving. So write a polynomial. I know what a polynomial looks like at this point, right? 3x squared plus 4x plus 5. It's going to be something like that, right? So a polynomial function f, this is telling me what we're going to name the function. So we're going to call it f of x. If they said write a polynomial function g, I would be writing g of x. Okay? Of least degree, we'll talk about least degree in just a minute, that has integral coefficients. Well, we know what coefficients are. What are coefficients? The number in front of the letter, correct? Okay, so where were we? Integral coefficients. We know coefficients are the numbers in front of the letters. Do you know what integral means in math?
Yes, integer.
Integer. What's an integer?
A number. What's a negative?
What kind of a number?
Negative or positive? Any number.
Negative or a positive, as long as it is not a fraction or a decimal. So this is saying that the polynomial you write has to have nice numbers in it. No fractions or decimals. Okay? And the zeros are 4, -1, and radical 5. So if I look at these zeros right here, my initial thought might be that the degree of this polynomial is going to be a third degree because there's 3 zeros. However, because of this, I need to know that if radical 5 is a 0, what are they not telling me? Negative radical 5 is also a 0. So what is the degree or the least degree of the function that I'm going to be writing? 1, 2, 3, 4. Not sure where 6 came from. Only the radical has a double. Only the radical. Only complex numbers and irrational, meaning radicals. Radicals come in pairs and i's come in pairs. The other ones do not come in pairs. So I have a 4th degree equation. So here's how I'm going to set up my equation. F of x equals, again, I'm calling it f of x because they're telling me to name it f. If 4 is an answer, what did the parentheses look like that 4 came from? X minus 4. What did the parentheses come from? Look like that -1 came from? Now, following that same pattern, what would the parentheses look like that gives us radical 5 as an answer? Follow the same pattern. I'm just going to call it x minus radical 5. And then for this one, I'm going to call it x plus radical 5. Don't try and go all the way back to the x squared thing, okay? Because we're going to multiply this out and it'll take us to that x squared thing, okay? So these guys, again, we just changed the signs and put them in parentheses. No, that's not what the parentheses would look like, but we're going to follow that pattern to get that. So here's what I'm going to do. I am going to multiply these two parentheses together and get an answer. And I'm going to multiply these two parentheses and get an answer. And I'm going to take those two answers and multiply them together.
That's it?
Uh-huh. Now, the hardest part of this problem is going to be the multiplying right here because we haven't done it with radicals, have we? So this is the part, every single time I want you to multiply the radicals first, or if there's i's in the problem, you need to multiply the i's first. Because when you multiply them, it will get rid of the radicals, or the i's. Okay? So, starting over here, x times x gives me x squared. What's x times radical 5? X radical 5, because the x has to stay outside, right? What's negative radical 5 times x?
You get multiplied actually based on the theorem. Isn't it just...
And negative radical 5 times positive radical 5 would be negative radical 25. We okay so far? What do you notice about these middle terms?
They have x.
They're going to cancel, right? So I have x squared minus, what is radical 25? Just 5. So if I do that process correctly, I should be done with my radicals.
So what would you...
So let's multiply this one. This one should be a lot easier, right? X times x is x squared. X times 1 is x. Negative 4 times x is negative 4x. And negative 4 times 1 is negative 4. Combining my like terms, I have x squared minus 3x minus 4. So at this point, I just need to multiply those together, and I'm done. So let's see. X squared times x squared is x to the 4th. X squared times negative 5 is negative 5x squared. Negative 3x times x squared is negative 3x to the 3rd. Negative 3x times negative 5 would be positive 15x. And again, you can use the box method if you want to. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 5 is positive 20. So putting everything in standard form, I have f of x equals x to the 4th minus 3x to the 3rd minus 9x squared, right?
Well, are you adding them together?
Mm-hmm. Plus 15x plus 20. I'm just combining my like terms. So that's what the function looked like that has zeros of 4, negative 1, and negative 5. So? Okay? Usually people find this a little bit easier, but again, the hardest part is multiplying those radicals there. Okay? For the next one, I'm not going to write out this whole paragraph. Just know that that's the same instructions. I'm just going to give you the zeros. Is that okay? So here are our zeros. 7 and 6i. What degree is my answer going to be? Third degree. Why? There's only 2 zeros. The I has to come in pairs. So that means that what else is a root? Negative 6i. So if I put all these in parentheses, the 7 would look like what? X minus 7. The i's, I would have positive 6i looks like, x minus 6i. And this one would look like x plus 6i. And that's what I have to multiply together. So I'm going to start off multiplying the i's, and then I will take the answer and multiply it by the x minus 7. Because like I said, multiply the i's first or the radicals first. That's what makes it easy. So let's do this one very carefully. X times x gives me x squared. X times 6i, 6xi or 6ix, doesn't really matter what order you write those in. Negative 6i times x would be negative 6xi or ix. And negative 6i times positive 6i would be negative 36i squared. Are you okay with that? Because that's the hardest step right there.
What would it be x minus 7?
It's right, x minus 7's right here.
No, but why? Why is it minus?
Because the parentheses has the minus sign so that when you add both sides, you get the 7 as your answer. X minus 7, you would set that equal to 0.
Oh.
That's how you get the answer of x equals 7. You have to change the sign. All right, so what happens here? These cancel. I have x squared minus 36i squared. Didn't I say that the i's would disappear?
Yeah.
And there's still one there. Do you happen to remember what I squared equals?
Didn't you say like 2 or something?
What is the definition of I? I is equal to what? The square root of negative 1. So what happens if you square a radical? The radical cancels out, leaving you with... So I squared is really negative 1. So I'm going to take this x squared minus 36, and instead of I squared, I'm going to replace it with Negative 1. So what does that become?
36, positive.
Mm-hmm. So I really have x squared plus 36 is how I got the answer of 6i and negative 6i. Yes?
Why can't you just do that to start off with? Like, why do you have to go through multiplying?
It's not always going to be that easy.
Oh.
And a lot of people can't get from there to there easily in their heads. They need to see the steps. Okay? I do want to see the multiplication because it's easier to find where you may have made a mistake also. All right, so what did I not address yet? The x minus 7.
Yeah, you said something.
So I just need to multiply those together and then I'll have my answer, right? X times x squared is x to the third. X times 36 is 36x. Negative 7 times x squared is negative 7x squared. And negative 7 times 36, need my calculator for that one. Negative 7 times 36, negative 252. Make sure your answer, however, is in standard form. So f of x equals x to the third minus 7x squared plus 36x minus 252. Okay, so? All right. Before I move on, I just want to make sure that we're all clear. I think there's one assignment on your homework that doesn't have radical 5. It has like 2 radical 5, something like that. It has a number in front. So just a reminder, if you have to take a number in front of the radical, let's say I have to multiply 2 radical 5 by 2 radical 5. You multiply the outside number by the outside number, and then the inside number times the inside number. That would be 4 radical 25, which becomes 4 times 5, or 20. Okay, does that make sense? Just a reminder, because I think you do have an example like that in your homework. All right, I have one more problem I want to do for you. Because these ones always get lumped together with the radicals and the i's, but they're slightly different. So here are my zeros. Negative 3, 3/4, and negative 1/2. What degree is my answer going to be? 3. Everybody always wants to take the fractions and lump them in with the i's and the radicals and make them pluses and minuses. You know, do the conjugate thing. They don't work that way. Fractions only come in ones. It's only radicals and i's that come in twos. So I do have a third degree equation here. I know that the parentheses that gave me an answer of negative 3 would look like what? X plus 3, right? Now I got to figure out what would the parentheses look like that gives me 3/4 as an answer. Let me work backwards for a minute. So if 3/4 is the answer, that means I have an answer that looks like this, correct? And I need to move everything to this side in order to get it to equal 0, which is what the original parentheses said, right? So I need to get back to something that says equals 0. And yes, I absolutely could just subtract 3/4 from both sides, but do you want to FOIL with a 3/4?
No.
I don't want to FOIL with fractions. That's just too much. So here's what I'm going to do. I'm going to start off by multiplying both sides by 4. That's going to give me 4x equals 3, right? And then if I need to get it to equal 0, what do I need to do? Subtract 3. So 4x minus 3 is what the parentheses looked like. That gave me an answer of 3/4. Do you follow that? Do I need to do that every time? No, because there's a shortcut. Where did the 4 end up? In front of the x. So that means I'm going to have 4x. The other number is going to be the 3, and since this is a positive fraction, I need to make it a negative to account for that moving over. So what would the negative 1/2 look like in parentheses? 2x plus 1. From here on, it's just multiplication. So the hardest part of that one is just putting it in the parentheses. So this one, It doesn't matter what order I go in, not like the radicals and the i's where you need to do the radicals first or the i's first. We just take 2 at a time and go from there. So x times 4x is 4x squared. X times negative 3 is negative 3x. 3 times 4x is 12x. And 3 times negative 3 is negative 9. If I combine my like terms, I have 4x squared plus 9x minus 9. And now I'm going to take that and multiply it by 2x plus 1. So 4x squared times 2x is 8x cubed. 4x squared times 1 is 4x squared. 9x times 2x is 18x squared. 9x times 1 is 9x. Negative 9 times 2x is negative 18x. Negative 9 times 1 is negative 9. And I think I'm down to my last step. F of x equals 8x to the third plus 22x squared minus 9x minus 9. And that's my equation. Okay, so you have an example to show you what to do when you have an I, an example to show you what you do when you have a radical, an example to show you what to do when you have fractions. Okay? All right, your homework is on Google Classroom. Happy studying.